Welcome. In this video lecture, I'm going to talk about how we can solve the multiple linear regression model using Python. So I will use two libraries. One is I'm going to use the Statsmodel library to solve the multiple linear regression model. Similarly, we will use Scikit-Learn. Okay. So for that, the problem I am going to use is basically the album sales. So this is the data set we have. So one variable is sales, that is basically indicating the album sales variable. Okay. Another one is basically the airplay, that is basically indicating the number of time a particular song from the album play on a radio. Okay, so that is the airplay amount of time. Another is attract, basically that is the attractiveness of the band. Okay, and the other thing, the last one, we have the advertisement budget, the how much we have spent on the advertisement. And this data set is basically we have collected from the 200 different albums. Okay, so for on this particular data set, we want to apply the multiple linear regression model, and we want to predict the sales. So that means our dependent variable is the sales variable, whereas all the other variables, the advertisement, airplay, and the attractiveness, are the independent variable. And we want to know that whether these variables are significantly affecting the sales or not. Okay, so let me go to the Python. So first of all, we need to import the libraries. So first of all, we need the Pandas library in order to read the data set, the CSV format. We need the NumPy as well as the matplotlib if I want to draw the plotting. But if I do not want to draw the plotting, then there is no need to get the matplotlib library. But the most important one, we need stats model, okay, as well as sklearn. So first of all, I am importing a library statsmodel.api as sm, okay, and from the sklearn library I am calling a module linear underscore model, and from there I am calling the linear regression. Okay, and the second thing, I am basically calling a module model underscore selection. So however, I would be able to split the data into the train as well as into the test. And the last thing, I am basically calling the module matrix. From the matrix I am calling mean square error as well as the r square in order to check the accuracy of the model. So let me run this command, and basically we have imported all these libraries. Okay, and I'm using the pandas library to read this data set, which is basically the album sales data. Okay, and this is the data set we have. So first of all, what we are going to do is I'm going to splitting the data. So I'm going to get the y value of the sale. So that means y is equal to as, that is basically the name of the variable in which we have the data set, which is album sales. So sales values. So it is up to you whether you would like only extract the values, or if you just write down y is equal to as sales, that is also fine. Okay, and next, the independent variables x's are advertisement variable, airplay, as well as the attractiveness. So this is how we are extracting the multiple variables. Okay, and we are storing into the x. So right now, this is the dependent variable, this is the independent variable. Okay, so if I am going to write down y over here, you can see that these are the dependent variable, which is the sales variable. If I'm writing down the x over here, so we can see that this is basically the independent variable. So as I mentioned earlier, even if I am going to use only this one, not representing the y, okay, not getting the values, okay, only the entire overall, that is also fine over here as well. Okay, so it's up to you whether you want only that extract with respect to y, or you want to write down this way. It's up to you. Okay, now, what we need to do is we are going to split the data into the training as well as the testing. Okay, so that is basically with the help of this particular module, that is the model selection, that is train underscore test underscore split function. Okay, so for that we are saying that x and y variable must be split into the training size. I am taking the 90 percent of the data is going to be split into the train, whereas the remaining 10% is going to be used as a test data. So it's up to you. Would you like to take 80% of the train and 20% of the test, or 90% of the train and 10% of the test? So right now I'm taking 90% train, 10% test. So it will randomly select the values or 90% of your data set as a train data, and the 10% is going to be used as a test data. Okay, and I'm storing this data set into the four variable. So x train, x test. So that means from this training data, the variables as we are considering as a independent variable from this x is going to be stored in 90% in this data set variable and 10% as a test data. Similarly, from this y, 90% is going to be stored in this training and 10% is going to be stored in this test data. Okay. Now we are going to fit the model using these train and test data. So for that, we have the two libraries from the Python. One is Statsmodel and another one is a Scikit-Learn. So first of all, let's develop the linear regression, multiple linear regression model using the stats model. So first of all, I'm going to develop the multiple linear regression model without intercept. Okay. So for that, how can I do that? First of all, I am saying SM, which means I am calling the stats model library. Okay, and then I am saying from the stats model there is a function called OLS, which is called as ordinary least square. Okay, then I am saying train the model on this y dependent variable train, and the test which we have taken this from this one. This is the train is the independent variable in which we have all three variables. Okay, that is advertisement, airplay, and the attractiveness, and then y train. Okay, so we are basically estimating the parameters of the multiple linear regression model, and then we are saying dot fit. So fit the multiple linear regression model, and then we are storing the result in a variable called lr linear regression, and with the help of this summary function lr dot summary we are basically printing the results. Okay, but right now the stats model is going to this fit model is without the intercept. Okay, so that means it is only showing y is equal to, which means sale is equal to beta 1 into the advertisement, beta 2 into the airplay, and beta 3 into the attractiveness. So if I would like to add that intercept as well in the model, so I need to call another function which is called as add underscore constant. Okay, so that's why I'm saying sm dot add underscore constant, and that constant must be added using the x underscore train data. Okay, and then we are creating another variable. Okay, that is x underscore train underscore sm, which means we are going to add the constant term. Okay, so now as a train variable we are going to use x train underscore sm. Okay, whereas y is going to be considered as it is. So basically we have added the constant term. Now we are again refitting the model and we are getting the summary results. So now you can see that we have the constant term. Okay, so this is basically the coefficient, which is beta naught. This is beta 1, this is beta 2, this is beta 3. Okay, so if I want to see that whether this advertisement variable, airplay, and the attractiveness are the significant variables or not, so as we can see from these p values, so because these p values are less than 5%, so that means these independent variables are significantly affecting the sales. Now the question is how much they are affecting. So that means by increasing 1 unit in the advertisement, our sale is going to be increased 0.081 time. Similarly, 1 unit of airplay is going to be increased, so the sale is going to be increased 3.143 times. Same is the case for the attractiveness. Okay, so all three are the significantly affecting the sales variable, right? So furthermore, it is basically showing on the training data that R square is 0.669, which is basically indicating that uh, these three variables. Okay, so that means the variation in the sales, these three variables are able to explain the variation in the sales up to 66.9% of the time. Okay, similarly, here the Durbin-Watson value is also important, that whatever the multiple linear regression model you have produced, so this Durbin-Watson test is indicating whether the error that the multiple linear regression is produced is are independent or not. So if the Durbin-Watson value is lying between 1 and 3, then we will say that is there is no issue that the errors are dependent. So which means they are independent. So that is not an issue. Okay, so once we have trained the model, okay, we have get the multiple linear regression model. This is beta naught, this is beta 1, this is beta 2, this is beta 3. So now I want to predict. So based on what? Based on the test data. Okay, so once again, I'm going to use the train test data, and I'm going to adding the constant. Okay. So once I have added the constant value, and I am getting another variable in which we have, after adding the constant term, then we are predicting. So now we are going to predict based on the test data set. Okay, and I'm storing into the variable called sales predict, and then I am saying print it. Okay, now the 10% the data which we have saved in the test part, using that one, it is basically predicting the sales. Okay, against those values, right? So this is basically the independent variables. So this is basically the sales we have predicted against those uh, test data set. Okay, so in order to check whether this prediction is good or not, so we have used the two type of accuracy metrics. Either we can use mean square error, either we can use R square. So how we can interpret it? So the smaller the mean square error, the better the model is. Same as larger the R square model, the better the model is. So first of all, we are calculating basically the mean square error. So for that, I am saying print mean square error. This is the formatted text. I am saying that show me the results up to zero point 0.2 digit. Okay, so this is the function of the mean square error which we have taken from this module, which is basically the Scikit-Learn metrics. Okay, so the function is mean square error as well as R square underscore score. So based on this one, we have calculated the mean square error against the y test data, which we have taken as a test, and this is the predicted value which we have done on the based on the test independent variable. Okay. Similarly, we are calculating the R square. Okay. So the value we are getting, that is basically this one. So remember that every time when we are going to run it, so these values are going to be changed, because the what is going to do is when we are taking the test and the train data, it is randomly picking. Every time it is going to be randomly picking the 90% values as well as the 10%. Okay, the random value, due to the random selection from your actual data set, these values is going to be changed. So we can see that the mean square error is 2206. Okay, and R square is 0.61. So which means the 60% of the variation our model is a good fit. Okay, the 60% of the variation our model is going to be explain the variation, or you can say having the predictive ability. So remember that these measures can be used as a comparative measure. So we have to apply the multiple models, 2 or 3 or 4, and then we will compare which having the smaller mean square error or which having the higher R square, or the coefficient of the determination. That particular model is the better model. The model having the smaller mean square error is the good one, and the model which having the higher R square value is the better one. Okay, the same result which we have get over here, which is basically beta naught, beta 1, beta 2, and beta 3, we can get using the another library which is called as Scikit-Learn. Okay, so using the Scikit-Learn, how we can fit the linear regression model. So as you have seen over here, we call a module called from the linear model. The function is called linear regression. So I'm going to call this one, that is basically I'm saying the linear regression. Okay, then dot I'm saying fit the linear regression model on what, on X train and Y train. So in a sklearn library there is no need to add the constant term. Okay, so we can directly apply on the train and test data whatever would you like. But right now I'm because training the model, because I'm estimating the parameter value of the regression beta naught as well as beta 1, beta 2 and beta 3. So I'm storing this data in a model, and in order to get the result from this variable, I'm saying that the intercept value model dot. Okay, so if I'm going to write on model dot, so there is a multiple thing I can get. So right now I'm interested in parameters or whatever you can say that parameters value. Okay, whatever the thing you would like. So right now I'm interested in the intercept, which is the beta naught value, and the coefficients, which is beta 1, beta 2 and beta 3 values. If I run this one, so I'm getting the same values which I have get from the stats model. Okay, this is point minus 29 point, this one, this is also minus 29, this one, this is 0.08. So this one is also 0.08 against the advertisement. So I hope you got the idea how we can apply the multiple linear regression model using the Python libraries of stats model as well as sklearn, and how we can predict using these libraries. So thank you so much. See you in the next video.